Good day, grade 7 learners. I am your teacher today. My name is DCP Gajano from Northeastern Mindanao State University. How are you this afternoon? Are you feel good? If you are, let's have an activity. This activity called Find Me. So, are you familiar with alphabet? Yes, I know. You are familiar with that. So today, you are going to find a numbers with corresponding letters. Here's the example. Look at the things around you. What makes you see the things aside from your eyes? Correct! It is because of the presence of visible light. Visible light makes us see things around us. But how does light behave so that we can see things beautiful creations? So, we have example here. The sun is an example of a natural source of light. The sun is capable of producing its own light. Other sources such as lamps, bulbs, and candles are examples of artificial sources of light. We have different scientists who spent a lot of time in understanding how light behaves. This includes Isaac Newton, who believed that lights behave like a particle. Second, we have Christian Huygens, who believed that lights behave like a wave. Third, we have Louis de Broglie, who believed that light can be a particle and a wave. Fourth, we have James Clerk Maxwell, who will propose the electromagnetic theory of light. The electromagnetic spectrum is where the electromagnetic waves are arranged in increasing frequency. Observe the illustration. Which half has the lowest frequency? How about the wave that has the highest frequency? As we seen in the illustration, radio wave has the lowest frequency and the gamma rays have the highest frequency. The only frequency of electromagnetic waves that is visible to the human eye is called the visible light spectrum. The visible spectrum is also known as a white light. When white light strikes into prism, it splits into visible light colors in electromagnetic spectrum. This phenomenon in which a prism separates white light into component colors is called dispersion. The component colors of white include red, orange, yellow, green, blue, indigo, and violet. These component colors are arranged according to the decreasing frequency. And visible lighting spectrum, light is one of form of energy that travels in electromagnetic waves. It behaves like a wave, thus it also has a wavelength frequency and amplitude. These properties have something to do with the special characteristic of light. Characteristics of light, which include intensity and color. Let us first discuss the intensity of light. Light intensity is the power of light. It is the quantity that measures the amount of light illuminating a surface. The science of measuring the intensity or brightness of light is called photometry. Luminous intensity. It is the amount of light that the object produces. It is measured in terms of candela. The brightness of light depends on how far you are from the source. From the source, observe the following picture. In which scenario will you see a brighter light? Correct! It is in the picture A. The closer you are to the source of light, the brighter is the light that you will see. On the other hand, if you are farther from the source, the dimmer is the light that you will see. Always remember that the intensity of light depends upon the amount of light or the number of photons that pass a certain area or space at the intensity or brightness of light. The intensity or brightness of light is also related to the wave's amplitude. The higher amplitude corresponds to a brighter light, while the lower amplitude corresponds to dimmer light. Next, we have characteristics of light, which is color. Color, as I mentioned earlier, visible light is the only electromagnetic wave that can be seen by the human eye. The component colors of visible light can be seen in the visible spectrum. The color of the light depends on the frequency or wavelength of the radiation that reaches the eye. Visible light falls at the wavelength range to 400 nanometers to 750 nanometers. What is the color of the light if the given wavelength is between 400 to 500 nanometers? Correct! It is color blue. When the wavelength of an electromagnetic wave is shorter than 400 nanometers, it is also called ultraviolet. And if it has a wavelength greater than 750 nanometers, is called infrared. Very good. Red has the lowest frequency and violet has the highest frequency. In general, the color white represents the combination of all the wavelength of visible light, while black is the absence of the wavelength.